Hi, DocRevis here with a short lecture on finding charges by math. And in this video, we'll show you with binary compounds. It's important to note that compounds are written with the most electropositive element first and the most electronegative element last. In other words, the element on the left side of the compound is positive, the element on the right side is positive. And that follows the periodic table trend, where in general, if you had two elements, the left element would be positive, the right element would be negative. So, for example, sodium chloride, sodium is positive and chlorine is negative. In titanium 4 oxide, titanium is positive and oxygen is negative. When we talk about a binary compound, it simply means you have two elements from the periodic table. Don't count these subscripts when you talk about whether it's binary or not, okay? It's basically one sodium and one chlorine, or one titanium and two oxygens, but it's oxygen and titanium. You get it? All right, so if we were to look at some examples, magnesium here, magnesium nitride, what you have is you have the magnesium with a plus and the nitrogen with a negative. So if we split it in half, you get a plus side and negative side. Same with its chromium and sulfur. Chromium would carry the positive charge, sulfur the negative charge. And this is by convention for compounds. When we write them, we write the electropositive part first, the electronegative part second, the carbon and bromine, nitrogen and oxygen. And if you look on the periodic table, you'll see nitrogen to the left of oxygen. And this makes sense for nitrogen to carry the positive and oxygen to carry the minus. And similar with water, H2O. So this is the convention for writing compounds. The electropositive part is first, electronegative part is second. And by the way, when you make compounds, you'll never put together two negatives and you'll never put together two positives. And you won't have the negative on the left side and the positive on the right side. You will always have a positive and a negative, and the positive will be on the left side and the negative will be on the right side. So here are the rules that we like to use when doing this. Are there other rules? Absolutely there are. Are there other ways of thinking about this? Yes, there are. But here's the way we'd like for you to think about it when you're finding in charges on binary compounds. 4 steps. Step 1, assign the negative side by the standard. In other words, there are standards for assigning the negative side. When you're using the math process, the first step must be to assign the negative side. That is, in general, the standard side of these binary compounds. So what are the standards? Group 17 minus 1, group 16 minus 2, and frequently group 15 will be used as minus 3. Okay. There's also one that likes to throw a hiccup in it. That is the hydride. Hydride, if a hydrogen is on the right side and it is a hydride, as in sodium hydride, then that hydrogen is a minus 1. You want to keep that in mind. So the first step is to put the charge at the top of the negative side. That is the first step. All right. Step 2, multiply for the negative side math balance. And note this is math balance. This is not the exact charge of the elements. This is the math balance between the positive influence or the particle positive side of the binary compound and the negative side of the binary compound. So we have a positive influence and a negative influence when we put these compounds together. The positive and the negative must balance out to be neutral. Okay? That is, if the compound starts neutral. And in the cases we're using here, they are all neutral compounds. So we have the charge, the negative charge times the atom count. Whatever the atom count, that gives the negative side math. That is for the math. This is not the exact charge of the element. So we multiply the negative side math balance and write it at the bottom. This is just for convenience where we like to tally the math. So the bottom numbers you're going to see in a minute will be numbers for tallying math. These are not the charges. We typically write the charges at the top of the elements. And in the examples here, that is the convention we'll be using. Step 3, set the plus side balance as a plus value equal to the negative. So if the negative, for example, is a minus 2, then the plus side would be plus 2. If it's a minus 10, then it'll be a plus 10. If it's minus 29, then it'll be plus 29. So the way we do that, the charge times the atom count will equal the negative side balance. And so we know we're going to take this negative side balance, and then we're going to set that to a positive. So it must add up to 0. So this is how you decide what it's going to be. Negative charge times the atom count gives you the negative side. And then you're going to set that, the left side now, to a positive. Get it? So it must add up to 0 for a neutral. All right? But start on the negative side to decide what the magnitude of the electric balance must be, or the electronic balance must be. Plus and the minus must balance out to be neutral. And we can find it by using this formula. Take this value, which will be the negative, then switch the sign to positive and write it on the left side. Okay? Number 4, do division multiplication math to find the plus charge. All right, so the right side, math divided by the atom count, will give you the charge on the positive side. So you basically take this balanced number that we did here, and you do some simple math, division or multiplication, and you will get the charge for the left side, which will be positive. So multiplication, division, then write the plus charge at the top. Okay? In general, we will write all of our math balance at the bottom, and that gives us the electronic values that must equal 0. Okay, the plus minus balance, if you will, must equal 0. All right? At the top, we write our charges. Okay? And the charge numbers will not have the same magnitude. They might, but they can have different magnitudes, plus minus magnitude. Okay? All right, so let's just take an example of this, make it simpler than all the discussion. Here we go. Let's look at how it really works out. Let's take, for example, the compound shown here. We have aluminum and oxygen, 2 aluminums and 3 oxygens. And so let's use step 1. Step 1 said we should assign the charge. We assign this as a -2 because it's from group 16, oxygen. Okay? Rule 2 says we should do a little simple math. 3 times -2 gives us -6. That's rule number 2. And so the negative side balance, and this is math balance for neutrality, is 6 shown here. All right, so rule 3 says, well, we've got to set that equal to 0. So that means the left side positive must be +6. And so this +6 minus 6 gives us electronic neutrality. And so we get a 0 there. Then rule 4. All right, get it? So let me recap. Rule 1, set the charge. That's established by standard. No math to do the first one. No math. You simply look it up or memorize it or borrow it from somewhere. Next step says do simple math. 3 times 2 gives us -6. So the negative side of this compound is -6. So we need to balance it off with a +6. Just simply calculate it here, transfer it here. That's what we did. We calculated here, transferred it here. And so we get a +6. Now we need to decide what number. We have 2 atoms of aluminum. So we need to decide what number times 2 would give us a +6 electronic balance. That means aluminum must be A + 3. And we write it at the top. So in the end, our charges in aluminum +3 and oxygen -2. We took these through the steps, 1, 2, 3, 4 steps down, and we get the charge of +3 and -2 for aluminum. And so this is a process you'll use. The numbers at the bottom are for math neutrality only. They are not charges. They are for helping you determine the charge balance based on the negative side must equal the positive side so that the compound is neutral. Let's take another example here. We have magnesium and bromine, magnesium bromide. So we have magnesium bromide and we want the charge on bromine and magnesium. So we split this in half. The plus side is going to be magnesium. The negative side is going to be bromine. By convention, that is what it's going to be. So we assign the negative side, -1. How do we know? Bromine is in group 17, therefore it is. Well, someone's going to say, well, what about magnesium? Isn't it always a +2 in group 2? Most of the time it is. But in general, it is generally better to choose the negative side because occasionally you will have, and many times, you will have positive sides that don't fit the standard. So by convention and by practice, we typically assign the negative side unless there's some overwhelming driving force to keep us from doing that. So in general, we suggest that you assign the negative side. So we assign the negative side of -1 here. That's step 1. And then step 2 says multiply 2 times -1 gives us an electronic -2 on the right side. And so we need to balance that so it can equal 0. Those are not charges. That's for electronic balance, so it can be neutral. And then we do simple math. 1 magnesium times +2 gives us a +1 for the charge on magnesium. Okay, so 1, 2, 3, 4 steps. Assign the charge, multiply, balance, new charge on the plus side. Let's do this next one here. We have chromium and nitrogen. And so we start with it. Step 1, we assign the negative side. In this case, we're assigning negative using the frequently used group 15 as a -3. Certainly this makes sense to us because chromium is a transition element and we certainly would not use it as a standard. So we'll use the group 15 as a standard. Therefore, it's -3 as number 1. And step 2, we multiply out here. 3 times 3 gives us a -9. Next step, we want to check for electronic balance to be 0. That means we must add a +9. So since we add a +9, we only have 1 chromium. That 1 chromium must carry that entire +9 charge. Okay, so let's just recap these steps. Step 1, we assign a charge as a -3 based on the standard group 15. Step 2, we multiply 3 times 3 and we got 9. Step 3, we then multiplied across here and we got a 9, and then we decided that we need to add a +9, and then we do simple multiplication, math, or division. And so 9 times 1 is 9, or 9 divided by 1 is +9. And there you have it. That's how we assign the charges for binary compounds.